So on this video, we're going to review graphing with slope-intercept form, y equals mx plus b form. And we should already know this form from the previous section. Whoops. So y equals mx plus b. If you understand y equals mx plus b, you know that your m is your slope, which is a rise over run. And the rise could be positive, that would mean it's going up, or the rise could be negative, that would mean it's going down. But the run, we're always going to be running from left to right, okay? And the b value, from the previous section, we know that the b value is the y-intercept. It's where it crosses your y-axis. So if it's in slope-intercept form, it's really a piece of cake to graph. So let's check out like number 1, for example, or let's do number 2. For example, the m value happens to be -1/2. The b value happens to be 1. If you're kind of confused, go ahead and write it down. M is -1/2, and b happens to be 1. Okay, so you start with b. Where's your b value at? It's at 1. That's your y-intercept. It says y right here. So where does it cross your y-axis? It crosses at 1, right here at this point. So we're going to put a solid dot right at that point. And now from that point, we're going to, see, the idea is this. You don't know if your line's crossing through that point like that. You know it crosses for a fact. It has to cross through here because that's your b value. That's your y-intercept value. So you don't know if it's crossing like that, or if it's crossing really steep like that, or maybe really steep going down, or maybe just kind of steep going down. How do you tell about your steepness of a line? By looking at your slope. So your slope here in this case is down 1 over 2. Now if it were positive, it would be going up 1 over 2, but it's negative, so you're going to go down 1 over 1, 2, and you're going to put a dot right there. And ladies and gentlemen, just draw your line through it, and you're done. Now let's say you wanted the line to be better drawn. You don't want to go crooked. You could keep going with the slope. Down 1 over 2, down 1 over 2. See, I went a little crooked, so technically I should end up right here. So you could make the line as long as you want by following the pattern of your slope. So let me, and you could also use that same pattern backwards. Instead of going down 1 over 2, you could go up 1 over 2 and put a dot right here. And you could also go up 1 over 2 and put a dot right there. So you could make your line as long as you want. Do you guys get it? All right, cool. So let's take a look at another example. That's how you graph using y equals mx plus b. Now, the problem with number 5, for example, is that it's not in y equals mx plus b form. So what do we have to do in order to look at this in y equals mx plus b form? You got to get y by itself. So you're going to divide by 2, divide by 2, divide by 2, and you will have y equals 3/2 x minus 1. Now what does that tell you? How do you graph this guy? Where does it cross the y-axis? What's your b value? Your b value is -1, so let's put a dot at -1. Now remember, this is your y-intercept. Here's your y-axis. This value right here tells you where it crosses your y-axis. It's not your x-intercept, it's your y-intercept. And then from that point, so far we know where it crosses. Now we need to know how steep it's going to be going through there. Really steep, steep going down, kind of steep, kind of flat. All you got to do is look at your steepness, and your steepness is rise 3, run 2. So from this point, you're going to go up 1, 2, 3, and over 1, 2. And you end up at this dot right here, and you're done. Okay? Let me show you how you could extend this line the other way if you wanted to. So instead of going up 1, 2, 3, and over 2, you could go backwards over 2 and down 3, over 2 and down 1, 2, 3 if you wanted to get to this point down here and extend the line as far as you want. So you could use that pattern of slope to extend the line as long as you want. Especially if you don't have a ruler, you might want to extend the line with the slope pattern. And then you just draw your line and you're good. Put arrows at the end. Yay? So we need to first make sure that it's in slope-intercept form. If it's not, we're going to have to modify it. Like 6, we have to modify by subtracting 1. 7, we have to modify by subtracting 1. Let's get to some of these that are so easy that you might get confused. Let's look at number 10. What is the m and the b on number 10? What's the m value? -3, and if you want it in the form of rise over run, you're going to say -3 over 1, correct? Yes, correct. Okay, so you're going to put -3 over 1. And how about the b value? Y equals mx plus b. What's the b value? 0. That's right. There's nothing out here at the end, so you're going to have a b value of 0. So don't get confused. That's pretty easy. All it's telling you is it's going to cross your y-axis at 0. So it's going to cross right at 0 on the y-axis. And now from this point, you're going to go up or down. Let me move this a little. There you go. So you can see that -3. It's down. So you're going to go down 3 over 1. You're going to go down 1, 2, 3 over 1. Put a dot right there. And ladies and gentlemen, you could just draw your line and you're done. Now let's say you wanted to extend it this way. Well, then use that same pattern but backwards. Over 1 this way, 3 up. Over 1 this way, 1, 2, 3 up. And you could put a dot right here. And you have your line extended, right? And that's how you graph. Easy peasy lemon squeezy. Let's go for another one that's so easy that you might get confused. How about number 11? What's the m right there? 1 over 1. Because you want it in the form of rise over run. How about the b value? 0. So we always start with the b value. You always start where it crosses the y-axis, which we know is 0. So let's put a dot on the y-axis at 0. And now from that point, we're going to go up 1 over 1, up 1 over 1, and put a dot right there. Now, of course, these dots are too close together. You want to extend it further with your slope pattern of up 1 over 1. So if you go up 1 over 1, you end up here, up 1 over 1, you end up here. And of course, you could go backwards. Instead of going up 1 over 1, you could go over 1 this way and down 1, over 1 this way and down 1. And you could extend it as far as you want. Very easy to graph, okay? How about y equals 2? Well, you could think of this, there's two ways of thinking of this. One way is slope-intercept form, and you say, okay, what's the m value? Since there is no x, right, y equals mx plus b, since there is no x, you say your m value is 0. And your b value, the number at the very end, that happens to be 2. That's one way of looking at it. Or another way of looking at it is to go old school and think of that function and make an XY table for that function and do inputs and outputs. Now the fact is that this equation says y equals 2. In other words, the only thing that this equation cares about is that your y values are 2. So we have our y values on this side, and we know that our y values have to be 2. Okay? And what about x? So like, if I want to plug in 0, where would I plug in 0? There is no x to plug it in, so it doesn't really matter what x is because there is no x in the equation. X could be 0, could be 1, could be 3, could be -4, whatever. But your y values have to be 2. So if you want to think of it in the form of XY table, go for it. The only thing that matters is that your y values are 2 and your x values could be anything you want. Now when you graph these coordinates, what coordinates? The 0, 2, the 1, 2, and the 3, 2, and the -4, 2, or any number in 2, what you end up with is this. Check it out. 0, 2 is right here. 1, 2 is right here. 3, 2 is over here. -4, 2 is over here. What kind of line do we get? A flat line. A line that has no slope that crosses the y-axis at 2. So you're probably thinking, well, why not just use this info? Crosses at 2, has no slopes, totally flat. Yeah, you could use this if you want. But the reason why I'm talking about the XY table is because that's the better way of making sense of number 13 over here, where you do have x equals 2. So you can't even write it in slope-intercept form because there is no y to get by itself. So on number 13, it's a great idea to make that XY table. Now, what's the only thing that this equation cares about? What does it say? X equals 2. So that's telling you that on your XY table, the only thing that this equation cares about is what? That your x value is what? 2. So you just write a bunch of 2's on the x. You only really need 2 points, but you could do as many as you want. And what about the y? Could be anything you want, because there is no y. So you could put a 0, 1, -2, +3, whatever you want. And now you can take a look at the coordinates 2, 0, which is right here. You go to the coordinate 2, 1, which is right there. 2, 3, which is right there. 2, -2, which is right there. What kind of line do we get? We get a perfectly vertical line. Okay? So if you guys are paying attention, something that you could jot down in your notebook or maybe right here on the side of this assignment is that when you have x equals 2, you will get a vertical line. And that's when x equals any number. X equals any number, you end up with a vertical line. Okay? It's going to be going straight up and down. When you have y equals any number, it's going to end up a horizontal line, like on number 12, or like on number 14 right next to it, right? Number 14 has y equals a number. So if you already understand that, now I want to give you the understanding of it though. And the understanding of it is x has to be 2, so your x values on your xy table has to be 2. The y values could be anything you want. When you plot these coordinates, you end up with a vertical line. But once you have that understanding, then you could look at number 14 and say, oh, y equals a number. Is that going to be a vertical line? Is that going to be a vertical line? No, it's going to be a horizontal line, right? So it's a horizontal line. Where's it crossing the y-axis? -3. So if you go to -1, 2, 3 right here and put a dot there, and you already know it's a horizontal line, you don't have to waste any time. You could just graph it. You're done. I hope this helps you remember how to graph using y equals mx plus b. Bless you. What I want to do right now is take it a step further, okay? I want to talk about domain since we already have some of these graphed. I want to talk about domain and range. So, specifically about domain. But let's say I told you to look at number 2 and I asked you to graph this equation, but let's say only with domain being x greater than 1. Okay, so this is going to get a little weird here, okay? If I'm telling you that the domain, what is domain? X's or Y's? X's. Domain, X's, range, or Y's. So if I tell you to graph this only with the domain x being greater than 1, then where is x being greater than 1? Well, here's 1. Greater than is to the right of it, right? So what we would have to do is kind of erase or block out or ignore the left side of it. Because if I'm telling you to graph only the domain values for x greater than 1, then that would mean that you would have to go back to this line, and at the value of 1, put an open dot on it and ignore the left side of it. Does that make sense? So you wouldn't actually have a line going full this way and that way. It would have an open dot here and going this way forever. If I told you for the domain values of x is greater than 1. Now you're probably thinking, why is he telling us this right now? Well, because on this next section, 2.6, you need to understand domain. Now, if this would have said, look at your domain values that are less than 1, then I would not be looking at this side of the line. I would actually be looking at this side of the line. Does that make sense? If I would have, let's say, x is less than 1, it would be an open dot, and less than is to the left, so you'd only be showing this part of the line. And that's just an intro on what we're going to need to be doing on this next section with regards to domain and piecewise functions.